Hello friends, my name is Vikram Balraj Sharma. I am a student pursuing my Masters in Mechanical Engineering at Indiana University, Purdue University, Indianapolis. Today I will be going to be presenting my project on design and analysis of shell and tube heat exchanger for my subject Mechanical Behavior of Materials under the supervision of Professor Jing Yang. So, the overview and introduction of my project. In this project, I'll be attempting to design, analyze and optimize a shell and tube heat exchanger. As we all know, heat exchangers are used for various purposes in the industry, and they are used in many industries. It's the most versatile and widely used in industrial sector to transfer heat between two or more fluids or liquids. I'll be carrying out my project in 3 steps. First, I'll be designing my shell and tube heat exchanger using Creo. The second step would be structural and thermal analysis of CAD model using the software ANSYS. And my third step would be optimization of the baffle parameters using ANSYS. That is basically the CFD analysis using ANSYS. So, the objective of my project would be to increase the efficiency. That's my basic objective. So, I'll be making various design changes to my CAD model on the basis and the results of ANSYS and the CFD analysis. So I would be changing the angles of the baffles, the size of the nozzles and placement of them in order to achieve the highest efficiency. This is the basic geometry of a shell and tube heat exchangers. As you can see, it's a shell within which there are various number of tubes in which the fluid is passed, and there are baffles in the shell which prevent the flow of the other liquid. There are various parts to it. As you can see, this is the inlet nozzle. The fluid flows from this throughout the tubes, and the other liquid which flows through the shell has this inlet from here. The tube outlet comes out from the channel outlet nozzle, and the outlet for the shell outlet is right here. In my project, I'll be using various materials to design the shell and the tubes as well. And for optimizing and increasing the efficiency, I'll be changing the angles of these baffles. As the angles are changed, the flow rate of the liquid would change, and that would affect the results of my heat exchangers on a large scale. That's the basic geometry of my heat exchanger. So, the material properties. Basically, all the standard shell and tube heat exchangers are made out of durable and high strength materials such as carbon steel or stainless steel. The inner tubes require an effective combination of durability, corrosion resistance and thermal conductivity. They are made up of stainless steel, copper or copper nickel alloy. For my project, I'll be using carbon steel, stainless steel, aluminium and copper. So, for the outer shell, I'll be using stainless steel or carbon steel, and I'll be using aluminium and copper inside for my tubes. So these are the various material properties like modulus of elasticity, yield strength, coefficient of thermal expansion, and thermal conductivity. The last two properties, coefficient of thermal expansion and thermal conductivity, are very important, as shell and tube heat exchanger see a lot of change in the temperature. So coefficient of thermal expansion and thermal conductivity are the two important properties for the design and manufacturing of the shell and tube heat exchanger. So guys, this is my CAD model of the shell and tube heat exchanger. I have designed this CAD model using the software Creo. I have designed various parts like the shell, the baffles, the tubes, and the upper, the bottom, and the front top, and I've assembled it in the same software Creo. As you can see on the section view, you can see the inlet of the fluid that would flow from the tubes, and this is the outlet for the same. This is the inlet for the liquid that would be flowing in the shell, and this is the outlet for the same. These are the baffles for which I'll be changing the angles. So this is the basic section of my heat and tube exchanger. What would be my next step? Like, I have prepared my CAD model. So the next step I would be doing would be performing the structural analysis on ANSYS and CFD using ANSYS. After these two analyses, I'll be getting some results. So as to improve on those results, I'll be optimizing the shell and heat exchanger by changing the angles of the baffles and changing some small properties of the nozzle, inlet nozzle, and the outlet nozzle. Thank you.